Hey guys, I hope everybody's doing well. We're just going to go over this worksheet that I signed for Tuesday, Wednesday. It was supposed to be turned in last night. I just want to make sure that everybody is on the same page and understanding the stuff that you're doing. So the example shows a homozygous green dragon with a heterozygous purple dragon. The first thing I would do in a situation like this is determine the letters for each. Homozygous green means that it's homo means same, right? So the letters are going to be the same. Yes, they're both G's, but they have to be either capitals or lowercase. In this case, because it's a capital letter, that tells us that it's dominant. Let me blow this up a little bit. It shows us that this is dominant here. And then this lowercase g indicates that it's recessive. This information was given to you, so you have no choice but to take it. It's recessive because it's lowercase g. So if I have a homozygous green, this is what's green, right? G. Homo means same, so that means I've got two G's. And then heterozygous means that it's going to be mixed. So we're going to have one uppercase letter and one lowercase letter, which is why the other parent looks like this. So then when we set it up, we've got this parent here, right? And then this parent went over here on the side, over here. Big G here and little g here. These are the parents. By the way, this would be the P generation. And then this would be our F1 generation. You didn't have to add this info. I'm just doing a little extra teaching here because it's what I do. All right, so we're going to cross these two and you get two big G's. Bring this G down, bring this one over. Big G, big G. So these two are the same, right? And then we've got big G, little g. And big G and little g. And so these two are slightly different, aren't they? Yes, they're heterozygous. Okay, so when you're figuring out your information for this section, you're going to refer back. It's asking us, what are the genotypes? Genotypes are the letters. These are the actual letters that you are going to write down. These are the genes as they exist. So if we look back at this, we have this genotype and we have this genotype. So all we have to do is write that down once. I don't need to write it again. It means the same thing. And big G, little g, and you're done. Then for this part, what is the genotype ratio? 2 to 2 or 1 to 1. How did we get that? Well, 1, 2 squares. We go to the most dominant first. So 1, 2. So we write 2, and then how many here? Big G, little g, there's 2 of them. So I would write 2 for the next one. So it's 2 colon 2. And then as we know in math, you can reduce that to 1 to 1 because a 2 can be reduced or cut in half to 1, and this can also be cut in half to 1. Okay, then the next question is asking you, what is or what are the phenotypes? Big G is green. It says it right here. G's are green. Now, when we get into the mixed, it's a little more complicated. So we have to refer back to the dominant. This means green and this means purple. The green is dominant to purple, so our phenotype is going to be green. And then what is the phenotype ratio? Well, let's go look back at our Punnett square. All of the squares here, this is green, this is green. We just said that this was green, so this is green too. So that means that all 4 of these are green. So when we write it here, we're going to write 4 for our green phenotype. And are there any other phenotypes? Nope. So we just put a 0. So it's 4 to 0. All the squares are green. Okay, so let's move on to the section that you guys had to work on. So some of you, because of the way that the Google Classroom loaded up my document, it shifted things. And it ended up loading the other document. I don't know what happened. Anyway, there were some issues with this. But down here, where number 3 is, it says a heterozygous curly-haired woman marries a homozygous. This, on some of the documents, it says hetero. This should say homozygous, straight-haired man. We can double check that when we get back there. Okay, so let me pull out a little bit here on this. And it says, a spotted lizard marries a homozygous blue lizard. Make a Punnett square showing their offspring. So here's the Punnett square, right? We need to break this information down. It's given to you that blue is dominant because that's the capital letter. So blue is dominant. That means that spotted is recessive. So a spotted lizard. So if I have a spotted lizard, this one right here, the only way that I can show spotted is to show the little L. And if I were to mix it with a big L, it's no longer spotted. This blue will overpower it and it'll be blue. So the only way to show spotted would be with 2 little L's. So let's write that for this first one. Little L. And then it's marrying a homozygous blue lizard. Homo means same, and blue. So here's blue. Capital L is blue. Homo means same, so we're going to need 2 of those. 2 L's. So, big L, big L. And then, so that gives us our parents. Little L, big L, big L. So let's put one parent over here. So here's one parent, big L, and the other parent was little l, little l. So when we cross these, I bring down the big L, bring this one over, bring this one down, bring this one over here, bring this one down, this one over, this one down, and this one over. Now, every square is the same, right? So what is big L, little l? Big L, little l would be dominant and recessive. So the dominant is always going to win, so it's going to look blue. So everything here is blue, right? So let's look back here. What are the genotypes? Well, they're all the same. So we have a very simple answer, which is L, L. Big L, little l, I mean. You don't need to write anything else. These are the parents, so you wouldn't write them down because we're looking at the offspring here. What is the genotype ratio? Let's go back here. How many squares have big L, little l? All of them. So 1, 2, 3, 4. So that means we're doing this again. 4, colon, and then nothing, which is represented with a 0. And then the next question is asking, what are the phenotypes? There's only one. Big L, little l, which gives us blue. So blue is our phenotype because that's the physical characteristic, which is blue. We already wrote the genotype up here. And then what is the phenotype ratio? It's the same, right? 1, 2, 3, 4. They're all blue. 1, 2, 3, 4. And there's nothing else, so it goes to 0. All right, moving on to the next one. So this is the one where I had a typo on some of the copies, if you looked at it earlier in the day. A heterozygous curly-haired woman marries a homozygous, it should be homozygous straight-haired man. Make a Punnett square showing their offspring. Okay, so curly and straight, that's already indicated here. So it tells you that curly is dominant. And this then would be recessive. And our directions tell us that there's a heterozygous curly-haired woman. So she's heterozygous. How do we represent heterozygous? Well, it's mixed, so we have to do a big C and a little c. So here's my big C, and I make it really obvious that's a big C and a little c. And then she married a homozygous straight-haired man. Let's look at what that would be. That's curly, so we can't put any of that in there. Straight has to be 2 little c's. So little c, little c. So this is the woman, this is the man. When you're doing genotypes, it doesn't necessarily matter in terms of the actual genes. So we're going to put this parent on one side of the Punnett square and this parent on the other side. So let's do that. So this is the mom, big C, little c. And then this is the dad. The reason I do this on the big C is that when you come over to this side and you don't see this, you can't tell if that's a capital C or a little c really. Sometimes. Okay, so let's cross them. Big C, little c, little, big C, little, little. So it looks like we have a half and half situation here. So let's answer the questions. What are the genotypes? The genotypes are big C, little c, and little c, right? Big C, little c, and little c, little c. It's basically the same as the mom and dad. And then what is the genotype ratio? 1, 2, 1, 2. So that's an easy one. 2 to 2, or 2:2. And then what are the phenotypes? Well, if this is a big C, that's curly, and this is straight, it dominates this. So these would be curly. And then these are both little c's, which are straight. So that means that these two would be straight. And I encourage you while you're doing this or when you're taking a quiz to make these notes on your paper to make it clear to yourself if you need to. That's helpful. So we've got curly and we've got straight. And the phenotypes here would be curly or straight. And then we're looking for a ratio on this one. So 1, 2 to 1, 2. Okay. Let's see. On a couple of papers, I saw somebody had put 4 to 0 over here. I'm not sure what happened there, but you got to make sure that you're crossing these properly. They may have mixed up, or they may have done a heterozygous off the original version. So if you did have hetero here on your paper, go back and change it to this just so you can check your answers and make sure that you get it right. The extra practice is not going to kill you. I think that was it in terms of things that stuck out. So I'm going to pull out a little bit and show this in its entirety so you can check your papers like so. There. Okay, hopefully this helps. Obviously, you can email me or use the Remind app and text me if you've got any questions on this stuff. We're going to do a quiz tomorrow. The quiz will be on the punnets like this and some Mendel questions. So if you just go back over your notes and study those, you should be fine. And I'm most likely going to put the quiz into Google Forms, but it's kind of hard with the Punnett squares. I'm not sure how I'm going to handle that part of it yet. So I might end up just doing it where you create the Punnett square and then you answer questions like this. That way you don't have to enter stuff into little squares. Anyway, I don't know. Still figuring it out. This is all new. Whole new world. Okay, hope you guys are doing okay and keeping up with stuff, and I will talk to you soon. Bye.